Welcome, I'm Joshua de Lisle, the designer blacksmith, and this is my still not yet finished workshop. However, if you're interested, we actually built this for next to nothing in a previous video, so do check it out. So the footage that I'm about to show you, I was actually really reluctant to share, which is why it's taken so long for me to actually release it. I didn't want people to think I was making that much money all the time, because I then hit a job where I made hardly any money. In fact, it nearly bankrupted me. Now, I don't expect you to believe this, but I'd actually quoted £500,000 worth of work, spending at least a month of my time designing and collaborating lots of things together, and it just turned out to be a waste of my time altogether. The client in question was a billionaire, so they could definitely afford it, but it's one of them. Anyway, I think it's important that as a metalworking community that we share these ideas and encourage one another, because it's the way we're going to be able to survive. Everyone will still want stuff done in the financial difficulties that are ahead, and so figuring out the most cost-effective solutions, I think, is the way forward. So the footage I took for this job was back in September, where I'd only just finished putting a roof on this workshop. So I'm going to go through the practical solutions using these 3 specific pieces of equipment, and then we'll discuss how I came to pricing it up and the financial side of it after. So I look forward to hearing your thoughts in the comments section and anything that you'd like to share with the rest of the community. But anyway, yeah, enjoy the video. So the first machine I'm going to show you is my Rohr MIG welder. Now, you may have seen me do a review video on this about a year ago. So this is the first time that I've given it pace. Set it through its paces and see what it's actually capable of. First up, I want to show you the upgrades that I got. I got a magnetic earthing clamp. That has really sped things up as far as setup goes, and I really like that. Excellent for pipe work as well. The main upgrade I got is a professional industrial torch for it. So the reason why I got this torch is because, one, I'm used to using these in industry. This is kind of like the standard for all industrial welding equipment. It has a nice big shroud that very rarely gets clogged up and is very easy to clean. It also dissipates the heat a lot better, so it doesn't overheat like the silly little hobbyist ones do. This one's actually rated to 360 amps and has just made production life far simpler. It means that it's fully reliable. It's also 4 meters long. The gas I'm using with it is called FerroWeld 12. It's a 12% carbon dioxide, I think 2% oxygen, and the rest is argon. And that seems to wet in the weld nicely and gives a nice clean weld with very minimal sputter. This machine cost me £300, but I regret not getting the slightly bigger version at 250 amps, as this is always being used on its maximum setting, and I don't like to run machines on their max all the time because it's no good for them. However, I've not had a single problem. It's not overheated or cut out on me, and has just been fantastic. So I do actually recommend this machine. And if you're interested in getting one, there will be links in the description of this video. The next most fantastic piece of kit that I highly recommend getting for yourselves is this plasma cutter. Now, it's rated at 50 amps and it comes with a P80 Panasonic torch rated at 100 amps. And these consumables last a very long time. In fact, to do all of the cutting that I do today, I use only a single electrode and nozzle per day. So very, very cheap and efficient to run. And again, this was extremely cheap at only £235, an absolute bargain. And last but not least, the handheld hole punch. Now, I've done a review on this also, but I bought this specifically for this job because there are so many holes that I need to put in this, and I've found a very quick way of using this tool, which I think you'll find very interesting. And this was £380, I believe, and I can tell you now it has paid for itself. So the first thing I've got to do today is to cut up all of my material, and for this job I'm using angle iron. This all has to be miter cut and welded together. Now, what you'd normally do is put it in the saw, but what I found is using the plasma is far, far quicker, especially when I use this technique. What I've done is I've made a cutting jig. So you'll notice that I've got a bit of a recess here, and that's on purpose. That's so I can keep the weld prep nice and square, as I'll show you. As you can see with this one that I've just done earlier, I've got a nice flat edge here, and it goes in line with the mitre there. But let me demonstrate how it works. Now on my plasma torch I've got these roller guides to the centre of the hole, 24 millimeters from the outer edge. I've got my square that's already set, pull the jig towards it, and then using these quick clamps secure it in place, just like so. Done. So I'm going to do the exact same thing on the opposite end of the jig, and that will give me the exact cut size without me needing to measure anything. I've done all the workings out on the jig, and that's made the rest of my life a lot easier. Now, depending on how steady you were, you will have a little bit of dross on your cuts just because you're doing it by hand. This will all come off in the prepping ready for welding, but to save me a big job, what I do is when placing it on the pile, I just go forwards and back a little bit. And it breaks off the dross on the previous piece of steel, saving you a bit of time. So this next cutting jig is even simpler for doing straight cuts. And all it is another piece of angle iron with a bump stop on the end, and the other end is set to the distance of my guide wheels of the plasma torch. No clamps needed for this one. The only thing I do need to do is just dress back the edge so it's nice and clean, ready for the next cut. But nothing more than a few strokes is needed. So now that I've cleaned up my parts, I'm simply going to mount them on this assembly jig. Now the assembly jig actually is one of the panels that I'm creating. So what I did is I made this completely square by measuring corner to corner, bracing it and welding it. And all I've simply done is put some tabs around it that the next parts can sit into. So every single one becomes a direct copy of the first one. So now it's all clamped, I can tack weld it and fully weld it together, all in place. So while I got it flipped over, you'll notice that for most of the weld I got full penetration, and that's because I leave a little gap. And increases the strength of the weld, but also means that I don't need to run the welder flat out. I can actually turn the settings quite down. Now the verticals, on the other hand, you'll have noticed I did vertical down, which is pretty much a no-no on most circumstances. But it's still bonded with the material and most of the strength is in the face, so I'm quite happy with it. And it's made it extremely quick. But for anything over 3 millimeters thick like this, I would always do vertical uphill welding rather than down. I'm very confident that these will not break though, and have come out very, very neat. So I've moved the jig out the way and I've stacked the finished frames over to the side here, and I've kept everything nice and close. The closer things are, the less travelling, the less faffing about, less time wasted, makes it more efficient. So we're going to do hole punching now, and I've got a little method for doing that efficiently. Now I could have punched all of these parts whilst they were in kit form, but as you can imagine with plasma cutting there is a bit of variancy in tolerances. So what I prefer to do is, once a frame is together, I know it's the correct dimensions, and therefore where I plot the holes from the outsides, the holes will be perfectly centered. And to do that I've got a template for doing it with. This simply sits on the side like so. I mark a line, and with these central holes I like to do it from both sides just in case there's any variancy. In this case there's not much, and what I do is I put the punch over the top like that, And then I actually look down at the line through this hole here. I can't show you really on camera, it's too dark. Just like that, we have a hole. Perfectly aligned up. With punches though, it does leave a little bit of a burr, so I like to go over it with the countersink drill bit just to deburr it. Because when it goes to powder coating does not like sharp edges, so it won't stick to it. So having nice radiused or beveled edges is what you want. For the corners, it's even more simple. I just simply butt the punch against the side like so. Now it's got a depth stop, so I'm getting into the center all the time, and I just take it all the way to the edge. And that is perfectly to the design. Okay, so I've just set the punch to punch holes in the end of this 30mm angle iron. Now it won't punch directly in the middle, but just off, basically in the middle of this bit instead of the full width. And the distance I need turns out to be just on one of the edges of the dies there, so everything lines up quite good to do both sides, as I'll demonstrate. Just looking at the edge of that line. Nice and quick, and now the other side. There we are, 2 holes. These are going to be my spacer bars, and so these holes have got to line up with the others. These take seconds to cut and seconds to punch. Put that against, say, a saw and a drill, and this wins hands down as efficiency goes. Okay, lastly we've got some mesh to cut. We're going to weld it together, and then we'll talk about how I priced this job, shall we? Okay, I've got to trim this mesh to size, and I'm going to do it simply with the plasma again. Now, I specifically chose this plasma to be a non-high frequency pilot arc. That means that I can use it to build a CNC plasma machine very easily. But it also means that it doesn't need to be in contact to create the arc, meaning that when I cut across gaps, like this mesh for example, it will cut fine. So this is what I mean by a pilot arc. It doesn't need to be touching the material. Honestly, that is just the best £235 I've ever spent. Even rounds it off for you. It's brilliant. So you'll notice that the mesh is actually over the top of one of the holes. That's not a problem, as the plasma will show you very shortly. But if my measurements are correct, this middle bar should align up exactly. A little bit of bowing in the steel. Oh, look at that. I shall now weld in place. Right, so I'm going to flip it over now and weld the other side, and then they're pretty much done, and we'll start to talk about business. But first things first, I've got some of the mesh in the way of some of the holes here. So I want to just show you the last little neat trick that you can do with the plasma. And that is using the fact that a plasma only likes to penetrate through one layer. You can't penetrate through multiple layers. You simply without damaging the rest of the frame is really simple. And for the other tricky bits, you know, where the hole is and it's in between layers, I can literally just pop the plasma in the middle and just blast it out. An absolute time saver and well worth the money. So there you have it. That's my process of fabricating these frames efficiently with the available equipment that I could get off Amazon. Now you could definitely go even quicker by investing in, say, a hydraulic punch and shear, like a Kingsland, for example, but that's like, well, second hand, they start at 3,000 British pounds. But it would definitely make its money back, as you can see, especially if I do this all the time. I don't. That's why I didn't bother to invest in one of those. But your main question probably is, how do I value a day's work at £600? So for a start, I make 4 of these in a day quite comfortably. That's starting from 8 o'clock and finishing around about 4:30, 5 o'clock. And the bid that I set was £150 per item. So my process when I price something, how many hours will it take to make one of these comfortably? And I couldn't see it taking more than 4 hours. And the other thing that I like to think of is, if I was to get a friend to make this for, say, £30 an hour, how much would that be? Regardless of materials, this is the actual wage cost we're talking about. So if I put my own commission on top of that, let's just say £30, that brings you to the 150. So with that in mind, thinking that I could comfortably make 2 in a day, that's how I started my bid. So if I was, say, overworked or didn't want to do the work, I could theoretically send it off to one of my friends and I'm still earning a bit of money out of it without doing anything other than a few emails and a few phone calls. But once a bid has been set and you've agreed a price, then it becomes piecework. So the faster you can create something to the high quality standard that they require, the quid's in, the more money you're making per hour, especially if your schedule is ram-stacked like mine is. You want to shift things as fast as you can. So understanding the price point at £150, passing that to the client was extremely happy. In fact, it almost sounded like they were prepared to pay more. But they're more happy the fact that it's getting done quickly, because they're under a time constraint also. So making the process of manufacture as fluid and as efficient as possible was the main thing. And all of the equipment that I've got here, even though it's cheap Chinese stuff, it's paid for itself within the first couple of days. But let's say, for instance, I did splash out on better equipment and got myself a nice Kempe welder, a Hypertherm plasma cutter, and a Kingsland press. They would have done the same job. It wouldn't have made it any quicker, really, other than the Kingsland, very slightly. But after splashing that kind of cash, I wouldn't have had much left over. See what my accountant says and see what the tax is going to come to at the end of the year. I may buy some of those pieces of equipment yet. Now, I could make over £1,000 a day doing this, but that means getting up extremely early and finishing extremely late, which my family wouldn't appreciate, and I value them more. So there you go. If you've got anything that you guys would like to contribute, then do let everyone know in the comment section below. Give it a like, subscribe, and that helps this information go further for other people. But anyway, what are you still doing here? Stop watching YouTube, get out there and forge a life worth living. See you in the next episode. Bye-bye.